Okay, this is grade 8. This is some of your practice questions from chapter 10 on solving linear relations. We like to call it just the algebra unit, but in all of these questions here, we have two-step algebraic equations that you're asked to solve with opposite operation. So in two-step equations, we were told that the first thing you should probably try to get rid of as you work towards isolating the variable is your constant. So in this particular equation, we have a coefficient of 2 and a constant of -5. So when I consider both of those, the first thing I want to get rid of is -5. And the opposite operation to subtracting 5 is to add 5, so I'll do so on both sides. I get 2x equals 16. I now have a multiplier of 2 left, which means we're multiplying our variable x by 2. The opposite of multiplying by 2 is dividing by 2. And our final answer is x equals 8. In the second question, it says negative 5x minus 1 equals 9. So here we have a coefficient or a multiplier of -5 and a constant of -1. So we're going to add 1 to both sides to get rid of our -1 constant, leaving us with -5x equals 10. Then we're going to divide both sides by the coefficient of -5, and x will equal -2. In our third question, we have a coefficient of 20 and a constant of -4. We're going to add 4 to both sides to get rid of our constant. We'll have 20x equals 2. And now when we have division by 20, I have divide by 20 and divide by 20. A lot of people say, well, I can't divide 2 by 20, but you can. If you think of it as a fraction instead of a division question, or sorry, 2 over 20. Let me erase that and try again. 2 over 20. If you think of it as a fraction, you could reduce this to lowest terms by dividing by 2. And an equivalent fraction would be 1/10. So if I use the calculator and say, well, if I grab my calculator here, there it is, 2 divided by 20, change it to a decimal, or if I said 1 divided by 10, it's both going to be the same decimal as 0.1. And the reason why that is because this is 1/10, and 1/10 as a decimal is 0.1. All right, so x is 0.1. And finally, question 4 on this page. Here we have a constant of 5 and a coefficient of 2. So we've reversed the order of our constant and our variable term with a coefficient. And you're supposed to see that. And you're supposed to know that the constant is still 5. But in order to get rid of it, I can subtract 5 from both sides. That's left with 2x equals -7. And then divide both sides by 2. And x will equal -3.5. Right? Half of 7 is 3.5. The negative divided by a positive is a negative. Questions 5, 6, 7, and 8 are just continuations, a little bit variations, but it's pretty simple. Question 5 is actually a question from grade 7. It wouldn't even be a grade 8 question because there is no negative variation in this, so it's just a grade 7 question. Constant is -3, so I'm going to add 3 to both sides. A fifth of x is equal to 4. Now remember, this particular expression can be written of various ways. A fifth of x, if I was to draw it, would look like that. It's a fifth of x. I could also write it as a fifth, where it is, a fifth multiplied by x. Or since a fifth is 0.2, I could write it as 0.2x. All of these expressions here are the same thing as a fifth of x. But when you say x over 5, the problem with saying x over 5 is the fact that you don't increase your understanding of what it means. You're just saying what it looks like. And you don't want to say what it looks like. You want to, if you can at any point, try and say what it is rather than what it looks like. So it's actually a fifth of x. There would take 5 of those to make a full x. So we have a fifth of x equals 4. And if I consider taking that fifth of x and multiplying it by 5, or the opposite operation to the other way we could think of it is x divided by 5, right? That's what it really is. Multiplying it by 5 and multiplying both sides by 5 will give me a full x equals 20. So the answer to question 5 is x equals 20. Question 6, we have a grade 8 version where we have this -half of x. Now, considering what we just said in the last question, a different way we could write this, if I grab my pen here, would be a negative half of x or a negative half of x, or I don't want to draw it because we don't like negative halves of x when we draw them, but both of those expressions do relate to the same thing. So if I asked you on a test, what's the coefficient of that expression, hopefully you wouldn't say, if I said true or false, the coefficient is negative 2, would you say true or false, the coefficient is negative 2? So we're going to add 1 to both sides, get rid of the constant. A negative half of x is equal to 1. Then we're going to multiply both sides by what we divided by to cancel each other out and to give us a value of x. So multiply the other side by negative 2. And you have the solution, x equals negative 2. Now don't forget, on a test, what should you probably do once you get an answer? You should go back into your equation, and I'll just bring it all down here. We get x equals negative 2, right? Take our x value, substitute negative 2, and I'll use blue this time, this would be a nice color, and see if this is true. If x is negative 2, then what is negative 2 divided by negative 2? Positive 1. And what's 1 take away 1? 0. So it does work, right? It does work. Okay. And our last question of this page is 5 take away 2x equals negative 25. What is the coefficient? What is the constant? The constant is still 5, but your coefficient, this time we have to take into account that negative 2. So your negative 2 is your coefficient, all right? So the first thing I'm going to do is get rid of that 5 by subtracting 5 from both sides. A negative 2x remains equals negative 30, right? The sum of 25 negatives and 5 more negatives is 30 negatives. And then we get rid of the coefficient. We divide both sides by negative 2. And x will equal a positive 15 because a negative divided by a negative is a positive. Oops, I skipped number 7. Let's go back to 7. So here we have a constant of 3. Show of hands, who can tell me what the coefficient is in this one? What is it, Zach? So the answer is the coefficient is 0.25 because really, if I think about, oops, that's the wrong color. If I think about a quarter of x, there's a quarter of x, or a quarter of x, a quarter written as a decimal is a quarter, of means multiplication, which is what a coefficient does. So technically the coefficient is not 4, but it's 0.25. So why did I say that? I don't know. Just because it's on your test, I know it is. Subtract 3 from both sides. A quarter of x is equal to negative 4. Multiply both sides by 4 to get rid of a quarter of x, because when you take a quarter of x and multiply it by a 4, you have a full x, and x equals negative 16. And your last two questions on this particular part of your test with opposite operation are your distributive property questions. A little bit complicated, but that's okay. If you think about the multiplication of these two, when we talked about distributive property, this is really a negative 2 multiplied by negative 2x and a negative 2 multiplied by a negative 2, because you're multiplying both of those parts in the bracket by negative 2. So a negative 2 times a negative 2x. Well, let's pretend for a second, and let's see if I can do this. Let's consider that those aren't negative. And I was to ask you, if I was to multiply this 2, there's 2x right there, and if I was to multiply it by 2, meaning double the 2x, right, I would have those 2x's, and I'd have these 2x's. So what would happen if you multiply 2 by 2x? You'd get, not everybody at once, 4x. But the difference between that is you're not multiplying 2 by 2x, you're multiplying a negative 2 by a negative 2x, right? This first one right here. Which means the only difference between doubling 2x is you have to also include your sign rules for multiplication. But fortunately, a negative times a negative is a positive, so we end up with a positive 4x anyway. And when we do our second arrow, this negative 2 times negative 2, well, a negative 2 times a negative 2 is a positive 4, so we're going to put a plus 4 in our expression. So when we expand that using distributive property, we end up with 4x plus 4 equals negative 2. We're going to subtract 4 from both sides. We get 4x equals negative 6. And finally, we're going to divide both sides by 4. And here we're going to have to think about mixed fractions or improper fractions. 6 over 4 is an improper fraction. As a mixed fraction, it would be 1 and 2 over 4, which as a lowest term fraction would be 1.5. So therefore, x is going to be equal to negative 1.5. Now, if you didn't know that, obviously, since you can have a calculator, you go 6 divided by 4 equals 1.5, and a negative divided by a positive is a negative. Now, alternatively, what could you have done instead? You could have simply divided both sides by what number? By negative 2. And if you did such a thing, which probably a lot of you did, you ended up with, instead of negative 2 groups of negative 2x minus 2, you ended up with one group of them, equals 1. At this point, you would add 2 to both sides to get rid of your constant. And negative 2x equals 3. Divide both sides by the coefficient. And the x is isolated, and its value is still negative 1.5. No matter which root you took, you got the answer of negative 1.5. Now, question 10. The distributive property is on the right, not the left, which makes it slightly more complicated, but not really. And inside the brackets, your constant is the first term, not the variable, which makes it slightly more complicated, but not really. So when I expand this using distributive property, negative 10 remains negative 10. But a negative 5 times this first 4, this first little arrow here, is negative 20. And this negative 5 times the x is going to be negative 5x. So now I have this expanded, and I'm going to simply get rid of my constant, which is 20. I get positive 10 equals negative 5x, and divide both sides by the coefficient. And the x is going to equal to negative 2. Right? How many expanded, just out of curiosity? How many divided first? Oh, so many of you. Okay. Well, in that case, let's look at division first then, because you do have to know how to do both. So it's good that I showed you that, because it will be on the test. If I divide both sides by negative 5, instead of having negative 5 times that expression, I'm going to have one of those expressions equals positive 2. Then I'm going to subtract 4 from both sides. And x is isolated, and the value is negative 2. All right, question, just before we go on. If this was a question on your test, and I said, true or false, the constant is negative 6. The constant is negative 6. Raise your hand if you believe that's true. Raise your hand if you believe that's false. You're all wrong. The answer is true. Because if you look at this and you expand it using distributive property, how many x's do you have? 2 x's. How many negative 3's do you have? So what's the constant? Negative 6.